All right, let's do section 10.2, page 496, exercise 1, which reads, use the formula in the definition to construct the fourth order Taylor polynomial at x equals 0 for the function f of x is equal to the square root of 1 plus x squared. Now the definition tells us that the Taylor polynomial of order n is equal to the summation from k equals 0 to n of the kth derivative of f evaluated at 0 divided by k factorial times x to the k. So if we want the fourth order Taylor polynomial, then we want n is equal to 4. So let's write out the terms that we're going to need. So P4 of x is going to be equal to the 0th derivative evaluated at x equals 0 divided by 0 factorial times x to the 0 plus the first derivative evaluated at 0 divided by 1 factorial times x plus the second derivative evaluated at 0 divided by 2 factorial times x squared plus the third derivative evaluated at 0 divided by 3 factorial times x cubed. And then our last term will be the fourth derivative evaluated at 0 over 4 factorial times x to the fourth. Now, the difficult part here is going to be to take the derivatives, which is not going to be as neat or as clean as it looks like it should be. So I'm going to go to a new page so that I can substitute my terms back in under where I've written out the formula for my fourth order polynomial. So let's go to another page, and we're going to remind ourselves that f of x is equal to 1 plus x squared to the 1/2. So if we begin with the 0th derivative, that of course is just the function. So that's going to be 1 plus x squared to the 1/2. And when I evaluate that at x equals 0, we are going to get 1. So what we're going to have to do is take the derivative at every step and then evaluate it at x is equal to 0. So our first derivative is going to be nice and easy. I'm going to bring that 1/2 down. I'm going to have 1 plus x squared to the negative 1/2. But then remember, we have to take the derivative of what's inside, which is going to give us 2x. And I'm going to evaluate that at x equals to 0. But because I have this x term out here, that's going to be equal to 0. And because I'm going to have to take another derivative, I'm going to clean that up and cancel the 2's. All right, so we need to take our second derivative now, and we're going to have to use the product rule. So I'm going to take the derivative of the first term here. Actually, I'm going to take the first term and leave it alone and multiply it by the derivative of the second term. And the derivative of that x is just going to be equal to 1. And then I'm going to take the second term and multiply it by the derivative of the first. So I'm going to bring that exponent down and get negative 1/2. I'm going to have 1 plus x squared, now to the negative 3/2, but I still have to take the derivative of what's inside, which is going to give me 2x. And when I evaluate this whole thing at x equals 0, my first term is going to give me a 1, but my whole second term here is going to be 0 because I've got this x here and this x out in front. So I'm going to cancel those 2's again because I have to take my third derivative. So my third derivative, and I hope that you're beginning to see a pattern here, I'm going to take the derivative of the first term, so I'm going to have negative a half times 1 plus x squared. Now it's going to be to the negative 3 halves. Again, I have to take the derivative of what's inside, which is going to give me 2x. For this other term over here, I'm going to have negative x squared out front. And then I'm going to take the derivative of the other term, and I'm going to have negative 3 halves times 1 plus x squared. Now it's going to be to the negative 5 halves. Again, I have to take the derivative of what's inside, which is going to give me 2x. And then I'm going to have negative 1 plus x squared to the negative 3 halves. But remember, I've got this x and this x, which gives me an x squared. So I have to take the derivative of that, which is going to give me 2x. And when I evaluate this at x equals 0, every term is multiplied by x. So that term is going to be equal to 0. All right, so now we're ready for our fourth derivative. And things are going to get a little hairy here. We could take a whole bunch of derivatives, but really we know that anything that's going to have an x in it is going to turn to 0 when we evaluate this at x equals 0. So I'm going to take a little shortcut here and try to eliminate, not even write down some of those terms. And if you have trouble with it, you should come and see me and I'll walk you through it. But first of all, I'm going to cancel these halves here. Okay. And if I take the first term, I've got 1 plus x squared to the negative 3 halves. And the derivative of this x is just going to be 1. When I look at this term over here, no matter what I take the derivative of, I'm going to end up with x's in it. So I'm not even going to worry about it because it's going to go away. This term, as long as I leave this first, so I'm going to have negative 1 plus x squared to the negative 3 halves, and then I'm going to multiply it by the derivative of this, which is just going to be 2. But when I take this times the derivative of this part, I'm going to end up with x's. So it's just not worth it to write it down. And I'm going to evaluate this at x equals 0. And when I substitute all of that in, I'm going to get negative 3. So now I have all of my terms here. Raise this up a little bit so we can see them all at once. And now I can go back to my first screen and substitute in what I need to substitute in. So here we go. And we said that f of 0 was going to be 1. 0 factorial is 1, and x to the 0 is 1. And then I'm going to have f prime of 0, which we said was equal to 0. And then I'm going to have f double prime, which is going to be equal to 1. 2 factorial is equal to 2, and I'm going to have x squared. F triple prime evaluated at 0 was equal to 0. And then the fourth derivative of f evaluated at 0 was negative 3. And 4 factorial is 24, and that's going to be times x to the 4th. So when I do a little canceling here, I'm going to get my Taylor polynomial centered at x equals 0 is going to be 1 plus 1/2 x squared minus 1/8 x to the 4th. And remember that this is centered at x equals 0.